Mars is silent now, a frozen desert, covered in red dust, broken rocks, and endless empty plains. No oceans, no rivers, no forests, no sound of rain, just wind moving through a thin atmosphere on a planet that looks completely lifeless. But Mars was not always like this. Billions of years ago, this world may have looked very different. Ancient rivers once carved deep channels into its surface. Lakes may have filled across the land. And where there is water, there is always one question. Could there have been life? Today, Mars is cold, dry, and almost completely dead. But hidden in its rocks is a story. A story about a planet that may have once had everything it needed to become another Earth. So what happened? How did a world with rivers, lakes, and possibly oceans become the red desert we see today? This is the story of Mars, the planet that may have lost its chance at life. Today, Mars is a world of silence. From space, it looks beautiful, a small red planet glowing softly against the darkness. But on the surface, Mars is harsh, cold, and almost completely lifeless. There are no oceans here, no rivers flowing across the land, no forests, no rain, and no blue sky like the one we know on Earth. Instead, there is dust, red dust, covering rocks, valleys, mountains, and endless empty plains. The atmosphere is incredibly thin, more than 100 times thinner than Earth's. It is made mostly of carbon dioxide, and it offers almost no protection from space. The sun shines in the sky, but its warmth barely reaches the ground. On Mars, the cold is extreme. Temperatures can fall far below anything a human body could survive without protection. But Mars is not completely still. Wind still moves across the surface. It lifts tiny particles of dust into the air and carries them across the planet. Sometimes these winds grow into enormous dust storms. Storms so large they can cover entire regions, and sometimes even spread around the whole planet. This dust gives Mars its famous red color. The soil contains iron, and over time, that iron reacted with oxygen, creating a kind of rust. Mars is, in a way, a rusted world. A planet covered in the color of something old, exposed, and slowly worn down by time. But Mars is not just a flat desert. It is a world of extremes. Here stands Olympus Mons, the largest volcano in the solar system. It rises so high above the surface that it would tower over any mountain on Earth. And across the planet stretches Valles Marineris, a canyon system so vast that it makes the Grand Canyon look small. These landscapes tell us that Mars was once powerful. Volcanoes erupted, the crust cracked, the surface changed, and something shaped this planet over billions of years. Today, Mars may look dead, but it is not empty of history. Every rock, every canyon, every layer of dust is part of a much older story. A story about a planet that once had energy, atmosphere, and perhaps even water. The Mars we see today is cold, dry, and silent. But that silence is not meaningless. It is the silence left behind after a planet changed forever. And to understand how Mars became this way, we have to look back billions of years, to a time when this red desert may have been a very different world. To understand Mars, we cannot look only at the planet we see today. We have to read the surface like an ancient record. A record carved into stone, dust, and dry valleys. Across Mars, scientists have found shapes that are difficult to explain without water. There are winding channels that look like old riverbeds, fan-shaped deltas where flowing water may have once carried sediment, and basins that could have held lakes for long periods of time. This does not mean Mars was once covered in life, but it does mean that long ago, Mars may have had one of the most important ingredients life needs: stable liquid water. In some places, Water may have moved slowly through valleys, and others, it may have collected inside impact craters, forming calm lakes beneath a denser atmosphere. These environments would have been very different from the dry world we know today. One of the most important clues comes from minerals. Certain minerals found on Mars usually form when rock interacts with water. They are like fingerprints left behind by a wetter past. Even after the water disappeared, the chemistry remained locked inside the ground, waiting for orbiters and rovers to discover it billions of years later. Ancient Mars may have had rivers that carried sediment, lakes that changed with the climate, and floods powerful enough to reshape entire landscapes. It was not another Earth, but it may have been closer to Earth than any world we see in the solar system today. For a time, Mars may have stood at the edge of habitability. Not alive, but not hopeless either. And that is what makes this planet so fascinating. Mars is not just a dead desert. It is a place where nature left behind evidence of a lost chapter. A chapter written in dry river valleys, mineral layers, and ancient lake beds. Somewhere in those rocks, the story of water on Mars is still preserved. The question is no longer whether Mars had water. The question is how long it lasted, where it went, and whether it remained long enough for life to ever begin. Jezero Crater is one of the key places in the search for ancient life on Mars. NASA chose this location because satellite images showed an ancient river delta inside the crater. A delta forms when water flows into a lake and leaves behind layers of sediment. On Earth, these layers can preserve chemical traces of past life. Billions of years ago, Jezero was likely filled with water. A river carried minerals, mud, and fine particles into the crater, creating layered deposits that still remain today. These rocks can help scientists understand how long water stayed there, what the climate was like, and whether the environment could support microbial life. The Perseverance rover was sent to study these rocks and collect samples. It is not searching for living organisms. It is looking for possible biosignatures, chemical or mineral evidence that could point to ancient life. Jezero Crater does not prove that life existed on Mars. But if Mars ever had microbial life, this ancient lakebed is one of the best places to look for its traces. Life, at least as we understand it, does not need a perfect world. It needs a few basic conditions: liquid water, useful chemistry, a source of energy, and enough time for simple organisms to appear and survive. Ancient Mars may have had some of these conditions. Its rocks show signs of past interaction with water. Its surface contained minerals that could support chemical reactions. Volcanic activity may have provided heat and energy below the ground. For simple microbial life, this could have been enough. But the surface of Mars was always a difficult place. Even in its warmer past, the planet was smaller than Earth, easier to cool, and more exposed to space. Radiation, climate changes, and a weakening atmosphere would have made long-term survival much harder. That is why scientists are especially interested in protected environments. If life ever began on Mars, it may not have lasted on the open surface. It may have survived underground, inside rocks, or in places where water and minerals remained available for longer periods. So the real question is not whether Mars looked alive. It probably never did. The question is whether microscopic life could have started quietly, hidden in water-rich environments, before the planet became too cold and too dry. No evidence has confirmed life on Mars, but ancient Mars had enough of the right ingredients to make the question scientifically serious. And that is why the search continues. The biggest turning point in the history of Mars was not a single explosion or one sudden disaster. It was a slow planetary collapse. Mars began to lose the atmosphere that once helped keep it warmer and more stable. An atmosphere is more than just air. It controls pressure, protects the surface, traps heat, and allows liquid water to remain stable. Without enough atmospheric pressure, water cannot stay on the surface for long. It either freezes, evaporates, or escapes into space. Early Mars likely had a thicker atmosphere than it has today. That thicker air may have helped support rivers, lakes, and a more active climate. But over time, Mars became vulnerable. The planet is smaller than Earth, with weaker gravity, and it lost its global magnetic field early in its history. Without a strong magnetic shield, the upper atmosphere was exposed directly to the solar wind, a stream of charged particles coming from the sun. Slowly, these particles stripped gas away from Mars and carried it into space. This process did not destroy Mars overnight. It happened over millions and billions of years, but the effect was enormous. As the atmosphere became thinner, the planet became colder. Surface water became less stable. Rivers stopped flowing. Lakes disappeared. The climate changed from active to frozen and dry. Mars did not die in a moment. It faded. Its air escaped, its water vanished from the surface, and a world that may once have been habitable became the cold, red desert we see today. Earth and Mars may have started with some similar ingredients: rock, volcanoes, atmosphere, and water. But their futures became completely different. The main reason is size and protection. Earth is larger, so it kept more internal heat. That heat helps keep its core active, and the moving liquid metal inside Earth creates a global magnetic field. This magnetic field works like a shield, protecting the atmosphere from the solar wind. Mars was smaller. It cooled much faster. As its interior lost heat, its global magnetic field weakened and eventually disappeared. Without that shield, the solar wind could slowly strip away the upper atmosphere. With less atmosphere, Mars lost pressure and warmth. Liquid water became unstable on the surface. Earth also had stronger gravity, active geology, oceans, and a climate system that helped recycle gases over long periods of time. Mars did not have enough of these protections to stay stable. So Earth survived because it remained active, protected, and warm enough. Mars failed because it cooled too quickly, lost its magnetic shield, lost much of its atmosphere, and became the dry, frozen world we see today. Could life ever return to Mars? Scientifically, the answer depends on what we mean by return. If Mars once had life and some of it survived underground, then life would not be returning at all. It would have been hiding there for billions of years, protected from radiation, cold, and the hostile surface. That is why future missions will not only study dry rocks, but also search for places where ice, minerals, and shelter may still exist below the ground. But if Mars is truly lifeless today, then life could only return in one way: by being brought there from Earth. That may happen unintentionally through spacecraft contamination, or intentionally through future human missions. This is why planetary protection is so important. Scientists do not want to mistake Earth microbes for Martian life, and they do not want to damage a world that may still hold its own biological history. Turning Mars into a living planet again is not something we can realistically do soon. The planet has low pressure, strong radiation, extreme cold, and no global magnetic shield. Building a stable biosphere would require changes far beyond current technology. Future bases may survive inside protected habitats, but that is not the same as bringing Mars back to life. So, the honest answer is this: Mars will not become a second Earth in the near future, but it may still answer one of the most important questions in science. Did life begin only once, here on Earth, or did it also begin on another world and then disappear? Mars may never become alive again, but its dead surface may still help us understand how rare life truly is. Mars is more than just a red desert. It is a warning, a mystery, and a record of what can happen when a planet loses the conditions that once made it active and possibly habitable. We still do not know if life ever began there, but every rover, every sample, and every new discovery brings us closer to the answer. Maybe Mars was never alive. Maybe life started there and disappeared. Or maybe, somewhere beneath the surface, the story is not fully over. If you enjoyed this journey through the history of Mars, leave a like, subscribe to the channel, and join us in the next video as we explore more of the universe. One mystery at a time.